What is data analytics? Data analytics is just a fancy way of describing methods we use to make sense out of data. So when we think of what data are, they're basically just numbers in a spreadsheet or words on a page, but when we're looking at those numbers and we're looking at text, our mind is doing a lot of the interpretation of what the actual value is to the numbers that we're seeing or to the words that we're seeing. But when we're starting to look at more complicated relationships, like looking at how different ecosystems are responding to change, we might have lots of different types of numbers, lots of different types of data that we're using to try and understand what exactly is going on in these systems. And when that's happening, usually we can't just rely on ourselves to be able to look at the numbers or look at the text and understand really what the underlying relationships are. So we have to start using math and statistics to really extract information from those data. So we use analytics then as a term to describe these methods that we use to extract that information. And some of these analytics can be as simple as just regression models that you might run as part of your algebra course, but sometimes they end up being much more advanced, much more sophisticated, because we really have to match the level of the complexity in our data with the methods that we're using. So some examples of data analytics that we use in practice can be summarized by forecast models. So we use forecast models as a way of predicting what might happen in the near future or even in the long term, like 10, 20 years from now. And when we develop these kinds of forecast models, we're usually developing models based on analytics that we've applied to understand how data that we already have can inform us about what might happen in the future. So we use data that we've collected and we develop these analytic tools based on the data that we have. And we try to understand from these relationships in data what might happen in the future by predicting with our analytics. So using the analytics, we actually form forecasts and other kinds of products that can then inform the way we make decisions. So an example of the way in which we're applying analytics is we're trying to understand how we can better predict what bacteria concentrations are in coastal waters. So right now we're using data that we've collected in the past where we just go and sample bacteria. We sample water to understand how much bacteria is in the water, and we're using those data to then develop models using analytics approaches that we can use to predict how bacteria concentrations change as a function of rainfall, as a function of land use, as a function of other types of water management practices, in order to better understand how we can prevent bacteria concentrations from getting too high in coastal systems. We're also using analytics to explore how sweet potatoes have different yields as a function of different types of practices like field practices, but also varieties. So we're trying to understand with both genetic information and also field-based information, how can we predict how sweet potatoes will grow differently under different environmental conditions. One way in which we're using analytics is we're trying to understand how we can better predict where flooding occurs. So one way we're doing this is we're capturing satellite imagery and we're applying different analytic methods to satellite imagery as a way of being able to predict what might happen when we have hurricanes occur. Can we better predict where exactly the floods will go to, and can we understand how exactly the flood is going to surge and retreat over time? So when we think about the way in which we apply data analytics, there's one component which is understanding the math and the statistics needed to apply these different kinds of analytic tools. But you also have to understand where the data came from. So especially when it comes to environmental and agricultural systems, you have to have a good understanding of how exactly these systems behave, such that you understand how the data, the numbers, the text that you've collected from these systems, how those numbers and text reflect actual real processes. So when we're applying analytics in these more applied contexts, like in agriculture and environmental systems, we have to understand how exactly to interpret the numbers so that we apply analytics responsibly. So computer science is a really broad field that includes developing different kinds of computational methods, but also applying those methods. But when it comes to computer science really bleeds across a lot of different disciplines. So you can apply computer science in different ways. So if you're interested in computer science, specifically in the application of computer science to help solve different types of issues surrounding agricultural and environmental sustainability, biological and agricultural engineering provides some really nice cases in which you can cultivate those same types of computational skills, but specifically in the context of applying them to environmental and agricultural systems. So you'll also learn about how the environmental and agricultural systems behave, what are important processes to know about, What are the underlying physics and biology and chemistry needed to really understand data collected from these systems and to apply computer science principles to study these systems?